Ah, welcome. Today is going to be a little bit different. Today, I am going to work through every problem on the assignment Continuing Accelerations. I realize that a lot of us have questions that I simply cannot answer during class. And sometimes the questions are about a process or just needing to watch a question get answered. So, hopefully, creating this for everyone will allow me to help people who have questions outside of what this video can answer. And I want to be clear. I really need you to remember the flowchart. What do you mean, Bozzuto? What flowchart are you talking about? I'm talking about this flowchart. When a question says how fast, there are two equations you can use. You can use speed equals distance divided by time, or you can use velocity equals acceleration times time. These are the two equations that you can use when it says how fast. When a question says how far, you can use the equation distance equals speed times time, or the equation distance equals 1/2 AT squared. So when a question asks how fast, you're looking for either speed or velocity. When a question asks how far, you're looking for distance. So here are the four equations that we have. All the work that we've been doing involves using one of these four equations. But how do I know which one to use? If a question says how fast, there's two equations to pick from. And the trick is going to be acceleration. You need to find out if there is an acceleration or not. If there is acceleration, you can use the equation that has an acceleration. Use if there is acceleration. If you read a problem and you don't see the word acceleration and you don't see the unit for acceleration, then you have to use speed equals distance over time. So no acceleration is speed, yes acceleration is velocity. And the same principle applies for the other two equations. Distance equals speed times time, you use this if there is no acceleration. Distance equals 1/2 AT squared, you use if there is an acceleration. So you need to understand how to find acceleration in a problem. You need to know how to recognize it. You got to know how to find it. And that's what's going to get tricky. So if you were saying, Bozzuto, I'm so lost, I don't even understand what's happening. Let's break it down. When a question says how fast, you're using either speed or velocity. And then you are going to keep reading that question to see if there's an acceleration. If there is an acceleration, you're going to use velocity equals acceleration times time. If there is no acceleration, you're going to use speed equals distance divided by time. If a question asks how far, you are looking for distance. You're going to use distance equals speed times time if there is no acceleration. And then you can use distance equals 1/2 acceleration times time squared if there is an acceleration. And what we're going to do now is examine how to find out how to do that. And I cannot stress this enough. I know we wrote it down. I know we've talked about this, but I wanted to put it here in this video because so that you could scroll to this timestamp. What is it, like 4 minutes, 45 seconds? And I want you to know that this is the list of units. So if you see M in a question, it means meters. If you see seconds, seconds. Meters is distance, seconds is time. Meters per second There's both speed and velocity, but this is the big one. If you see meters per second squared, that is an acceleration. If you see that, then you know you need to use an acceleration equation. This is the first question. This is the first question on your sheet. And these are the things I want you to do to set up all questions. So take some time. Maybe you want to split screen it. Maybe you want to have this video playing on your phone. You're looking on your Chromebook to type it in, because we're going to fill this in together. This first question says, how fast? So I know I'm looking for either speed or velocity. So I know that of the 4 equations, it's either going to be speed equals distance over time, or it's going to be velocity equals acceleration times time. I don't know which one yet, but just because it says how fast, I know it's one of those two. When you read a question, you need to make a list of variables. When I say list of variables, I need you to read the question and find all the numbers. 3 meters, 40 seconds. These are your variables. These are the things that we know. But what is 3 meters? 3 meters is a distance. And 40 seconds is a time. We know that from the unit chart. Go back to 4:45 if you don't know that. So because we have a distance and a time, because it says 3 meters and that's a distance, and 40 seconds, that's a time, under list of variables, I need you to write d equals 3m, distance equals 3 meters, and t equals 40 seconds, time equals 40 seconds. So because I have a d and a t, and there's no acceleration, there's no a in this list. There is no a in this list. There's no meters per second. There's only one equation that has it. We're going to be using this equation. That means if we're using this equation, we're looking for speed, not velocity. You're only looking for velocity if you have an acceleration. We do not have an acceleration. So in the box, what are you looking for? I want you to write speed, or S. The equation you're going to use is speed equals distance divided by time. So then what we have to do is we have to plug it in. We have to solve. The distance was 3 and the time was 40. So in our calculators, we are going to type 3 divided by 40, and we're going to get 0.75. And the unit for speed is meters per second. This is the final answer. If you want to get full credit, I need to see all of this written in your box. Let's do some more. How fast? Okay, this is either going to be speed or velocity. I don't know yet. I have to keep reading. I have to make a list of variables. How fast does a duck go that accelerates from rest plus 2m/s squared for 4 seconds? Okay, list of variables time. When it says 2m/s squared, I know that m/s squared is an acceleration. That's just something I know. And because there's an acceleration, I know there's certain equations that I can use. 4 seconds is a time. Awesome. So it says, how fast does a duck go? How fast is either speed equals distance divided by time, or velocity equals acceleration times time. But because we have an acceleration, because of the unit m/s squared, it actually tells us a lot. It tells us that we are looking for velocity. This is the only equation that has acceleration, so this is the equation that we are going to be using. Whenever there's an acceleration, you are looking for velocity, and the equation that you use is v equals at. I know this because of the acceleration. That's why acceleration is so important. So what we're going to do is we are going to solve v equals, what goes in for the a is +2, the time is 4. Oh, okay. v equals +8 m/s. This is your answer. This is everything that you need to write. You need to write all the stuff that's in the box in order to get credit for the problem. How far? Okay, now we have a how far question. When it says how far, we have two equations. Distance equals speed times time, or distance equals 1/2 at squared. These are our two equations. I have no idea which one it's going to be. I just don't. I don't know which one it's going to be. I have to read the question. How far does a kayak go that was rowing 3m/s? M/s. Why, in 18 seconds. 3m/s is a speed. 18 seconds is a time. I don't see the word accelerate. I don't see the word or the unit m/s squared. Do not call this an acceleration. This is a speed. It's not an acceleration. That is the biggest mistake that people have been making so far. They are not recognizing the units and they're calling that an acceleration. Because it's just m/s, it is a speed. So what are we looking for? We are looking for a distance. Distance equals question mark. So the equation that we're going to use is distance equals speed times time. How did I know to use that equation? Because I had an s and a t. I don't have an a. Because I don't have an a, I can't use the equation that has an a in it. I have to use the equation that has an s and a t in it. That's how I know. Your variables have to, from the list of variables, have to match the equation. This equation has an s and a t. I have an s and a t. The other equation had an a and a t, and I don't have an a. I don't have an acceleration, so I cannot use that equation. And then you solve. I just plug in distance equals 3 times 18. Distance equals 54 meters. That's it. That's all you have to do. How far? Stop. What are you looking for? You're looking for a distance. Because of those two words, how far, I know it's going to either be distance equals speed times time or distance equals 1/2 at squared. Well, I don't know, so I got to make a list of variables. How far will a ball go that was accelerated +1 meter per second squared? Meters per second squared, meters per second squared. I feel like that's important. Oh, that's an acceleration. So in my list of variables, that's what I'm going to write. +1 meters per second squared for 5 seconds. Seconds is time. Okay. So we have an acceleration and we have a time. We are looking for a distance because it says how far. There is only one equation that has DAT. Only one equation has DAT. And that's going to be this one. Because it's an acceleration, I have to use, because there is an acceleration, I have to use the equation that has an acceleration. I can't use this equation because there's no acceleration in it. It doesn't match my variables. That's why I am pressed about making the list of variables. So, what we're then going to do is solve it out. I am going to plug these numbers into this equation. D equals 1/2. Instead of the A, I'm going to put 1. Instead of the T, I'm going to put 5. So all I've done is taken from my list of variables, and where it says A, instead of saying A, I put in the number that it equals, 1. Instead of T, I put the number that equals 5. And I said that all you have to do is order of operations for this. What do you mean when you say order of operations, Pizzuto? Order of operations means you do exponents first. So I'm going to leave the 1/2 of the 1 alone. And then 5 squared is 25. And now, all I do is type this in my calculator. 1/2 can be written as 0.5. So you could type 0.5 times 1 times 25. If you don't like messing with decimals, you can also think of as 0.5 as divide by 2. So you could do 25 times 1 divide by 2. Either way you do it, you should get the answer of 12.5 meters. And it is so important that we feel comfortable using this equation. I know it's a little tricky, so let's look at another one. How fast? Okay, how fast? Because I see the words how fast, I know it's either speed equals distance over time or velocity equals acceleration times time. I know that because of the words how fast. That's what I know. Does a ball roll? If it rolls for 5 seconds, okay, 5 seconds is my list of variables. T, 5 seconds. I hope we know that seconds are time. With an acceleration of plus 3 meters per second squared. Meters per second squared. When I see that unit, my eyes need to be bursting out of my head. I need to be like, yes, meters per second squared. That is an acceleration. The acceleration is plus 3 meters per second squared. Yes. So there's only one equation. There is only one equation that has an acceleration at a time that solves for how fast. That means we're looking for velocity, because whenever we have acceleration, we're looking for velocity. Acceleration and velocity are connected. So the equation that we're using is velocity equals acceleration times time. I plug in velocity equals 3 times 5. Velocity equals plus 15 meters per second. This is how it works, always. You read the problem, you make a list of variables, you figure out what you're looking for, you pick the equation, and then you plug in. How far? Now we're looking for distance. Now we're looking for distance. But I don't know which equation. I have 2 equations to pick from. How far does a bowling ball go that travels down a lane in 1.5 seconds? Okay, that's a time. 1.5 seconds is a time, I'm pretty sure. While moving 11 meters per second. 11 meters per second. I'm pretty sure that's a speed. And the reason I know it's a speed is because meters per second could be speed or velocity. And because I don't see the word accelerate anywhere, I don't think we're dealing with velocities. So I'm looking for distance because it says how far. Because it says how far. That means the equation I'm going to use is distance equals speed divided by, speed times time. Excuse me, speed times time. I am simply going to multiply these numbers. The speed is 11. The time is 1.5. And I do in fact get 16.5 meters. Do not be afraid of using your calculator. That's it. How far? Okay, we're looking for distance again. Does a cat go that accelerates from rest plus 7 meters per second squared? 7 meters per second squared. When I see that unit, I have to know that that means my acceleration is plus 7. We just have to know that. For 3 seconds, the time is 3 seconds. The time is 3 seconds. And I know I'm looking for distance because it says how far. The distance equation that has an acceleration is the one that we all love. D equals 1/2 AT squared. That's the equation we have to use. When you see that equation, I know some people get intimidated, but don't get intimidated. You know how to do this. We're just going to plug in our variables. I'm going to bring down the 1/2. A is 7. 3 squared. Bam. Bam. I just plugged into that equation. I then said, order of operations is what has to happen next. Order of operations is what has to happen next. Order of operations is what has to happen next. 3 squared is 3 times 3, or 9. Now that I have 1/2 times 7 times 9, I could just plug it in my calculator. I could type 0.5 times 7 times 9, or I could type in 9 times 7 divided by 2. It doesn't matter. It doesn't matter. But ultimately, you need to make sure that your calculator says 31.5. Because that's the answer. Nice. How far does an eagle fly? How far does an eagle fly that accelerates from rest 18 meters per second squared for 4 seconds? Okay. How far means I'm looking for distance. When I see 18 meters per second squared, that's an acceleration. The time is 4 seconds. What are you looking for? Distance, of course. So we have DAT, D-A-T. When you've got DAT, there's only one equation you can use. You have to use the distance equation with acceleration. Everyone's favorite acceleration. I don't mind practicing this equation a bit more. I want us to feel comfortable with it. D equals 1/2 AT squared. Okay, first step, plug the numbers into the equation. D equals 1/2 18 4 squared. Okay. So the acceleration was 18, so A 18. The time was 4, t4. Okay. All I did was plug in. That's not scary. That's not scary. Order of operations says I have to do exponents first. D equals 1/2 18. 4 squared is 16. Now you just have to type it in your calculator. And there's so many ways you can type this in. You could do 0.5 times 18 times 16. You could do 18 divided by 2 times 16. You could do 18 times 16 divided by 2. You could do it any order you want. Multiplication is commutative. But regardless of how you type it in your calculator, you should be getting an answer of 144 meters. How far? Oh, are we doing that same equation again? It says how far. I don't know. I actually don't know until we read the problem. How far does a llama walk if it travels plus 16 meters per second in 7 seconds? Oh, there's a plus here. Does that matter? Well, is there an acceleration? Do I see acceleration anywhere? No, no acceleration. So we're going to call that a speed. If there's no acceleration, it's a speed. For our purposes, it's speed with a direction. We just know 16 right. The time is 7. I'm looking for distance. We're not going to use that distance equation that we did the last two problems because we don't have an acceleration. No acceleration. So this is just distance equals speed times time. Yes. And of course, when you type 16 times 7 in the calculator, you get 112 is your answer. Thoughts, problems, questions, concerns? How fast? Okay, we haven't done how fast in a minute. How fast? How fast? How fast? I don't know. Speed or velocity? Speed or velocity? Don't know. Don't know. Does a yellow jacket fly if it moves 0.4 meters? 0.4 meters. That's a distance. So I'm going to write distance equals 0.4 meters. Oh, okay. How do I know that was a distance? From the list of variables. We've got to know our variables in units. 2.3 seconds. Okay, 2.3 seconds. That's a time. 2.3 seconds. Okay. How fast? Either speed or velocity. Is there an acceleration? No acceleration. I don't see m/s squared anywhere. Because there's no acceleration, that means I'm looking for a speed. Speed equals distance divided by time. Speed equals 0.4 divided by 2.3. Speed equals, let's just say 0.17. I like 2 decimal places. 0.17 meters per second. I know there's more digits. You type that in your calculator. I know that. I know that. Nice. How far? Okay. How far? That's a distance. Oh, we're back to distance. Okay, let's see. Is this going to be the one we don't like? I don't know. Does a moose amble if it accelerates from rest? Whenever I see the m/s squared, and I know I have an acceleration, I know it's the more complicated equations. Every time I see m/s squared, I know it's either going to be v equals at or d equals 1/2 at squared. And in this time, because it says how far, I know I'm looking for a distance. The equation that has a distance and acceleration is everyone's favorite d equals 1/2 at squared. D equals, I'm going to plug the numbers in. We're going to go slowly through this one. The A is 2. Okay, A is 2. And the T is 7. The A is 2. The T is 7. Okay. Thank you. I almost forgot to write the squared. That is a common mistake that people make, and they forget to write the squared, and then they don't get the right answer. I'm going to bring everything else down except for the exponent. 7 times 7 is 49. So I have 1/2 of 2 times 49. So I could type it in any number of ways. I could type 0.5 times 2 times 49. I could do 49 times 2 divided by 2. Either way, you should be getting 49 as your answer. How fast does an ibex go? Ibexes are great animals. They can walk up and down mountains. They're really cool. You should go Google ibex videos if you're bored. Not that you'd be bored doing this. How fast? Speed or velocity? Don't know. Does an ibex go if it travels 38 meters? That's the distance. In 9 seconds. That's a time. What am I looking for? I'm looking for speed or velocity, but there's no acceleration, so it's definitely not velocity. I'm looking for speed. Speed equals distance divided by time. Speed equals 38 divided by 9. Who thinks that's 4? Who thinks that's 4? It's not 4. It's actually 4.22 meters per second. I feel like these are going faster. Once you know what you're doing, the process is always the same. How fast does a fox move? Okay, so how fast? Either speed or velocity. If it accelerates from rest, oh, that dreaded acceleration. It's right there. A equals +6 meters per second squared. 6 seconds. Time. Okay. So when it says how fast and there is an acceleration, you are actually looking for velocity. Because we have an acceleration, we know that we're looking for velocity. That means the equation that we're going to use is v equals at. And when I plug into that equation, 6 times 6, velocity equals plus 36 m/s. Nice. Last one. We did it almost. How far? That's distance. Is there an acceleration? Does a rocket go that accelerates from rest? There is an acceleration. Okay. List of variables. A equals +12 meters per second squared. For 15 seconds. 15 seconds is time. Time equals 15 seconds. All right. When it says how far, that means I'm looking for distance. Okay. So if I have an equation that has solves for distance, uses acceleration times time. acceleration and time. That's going to be everybody's favorite. D equals 1/2 a t squared. Plug and chug, my friends. We know how to do this. Don't be intimidated by the numbers. Don't be intimidated by anything. You know the process. The acceleration is 12. The time is 15. And just the time gets squared. Order of operations says do the exponents first. So I bring everything else down. I cannot stress this enough. You only square the time. That's why I've been showing you how to do the work like this, because people have been messing things up, but you only square the time. 15 times 15 is 225. When I type that in a calculator, I could type 0.5 times 12 times 225. I can type 12 divided by 2 times 225. I could type in any number of things, but just make sure that when I type it in, this is the answer that I get. That's how it's done. And that's it. This is the culmination of all the acceleration equations that we've been using. I hope that this gave you guys a chance to really look through the problems, understand how to do that, have a better approach to, better way to solve it, better approach to these problems, and it gives you a little bit more confidence to do them on your own. Rewatch this at your own pace, take your time, and don't forget to like and subscribe.